Hi, everybody. Okay, so yesterday we learned the fundamental theorem of arithmetic, which says that for every number that is bigger than 1, that number is either prime or is a product of prime numbers. Okay, so if I have a number like 24, this number is not prime. So I can write this as a product of prime numbers, and I know that 24 is going to be, let's do a factor tree, 8 times 3, 8 is going to be 2 times 4, and 4 is going to be 2 times 2. So here are my prime factors. So I know that 24 is equal to 2 times 2, 3 2's times 3. Okay? And the other thing that the fundamental theorem of arithmetic says is that this product is unique. Okay? There's no other combination of prime numbers that will give me 24. This is the one and only combination. All right, now, one of the cool things that we can take from this is that every factor of 24, now that means that every number that divides into 24 that's greater than 1 has to be some combination of these prime factors. And I'll show you what I mean. So 24, let's go through some factors of 24. The factors of 24, I know 1 times 24, I know 2 times 12, I know 3 times 8, and finally 4 times 6. Now, every one of these factors, except for 1, all the ones that are bigger than 1, has to be some combination of these prime factors. Now let's take a look here. Okay, let's see. So 2 times 12. Let's just see 2. So first of all, 2 is right here. Okay, I can easily find 2. And what would I have to multiply 2 by? Well, I'd have to multiply it by whatever's left. So 2 times this. What's this? This is 4 times 3. This is 12 here. Okay, so we found 2 and 12. Let's see what else we can find. 3. Well, 3 is right here. What do I multiply 3 by to get 24? That would be whatever's left, which is 2 times 2 times 2. That's 8. Okay, so again, we're finding these factors in the prime factorization of 24. Okay, and that's going to help you with your activity tonight. It's going to help you with number 14B, and it's going to help you with the activity that is going to be online. Okay, so let's get rid of this. Let's try some more. And let's see, we already did 3 and 8. So now we're going to find 4 and 6. Well, 4 is 2 times 2. That's right here. And our 6 is what's left. Okay, so I hope you can see that every factor of 24, except for 1, can be made by combining its prime factors. Okay, so let's start fresh here. Let's get a more complicated number. Some of your homework problems are going to look like this. We'll have a number like 144. You know, I really like this blue. We're going to stick with this blue. So we're going to take 144. And I'm going to ask you a question like, is 16 a factor of 144? So I'm going to write that down. Is 16 a factor of 144? Now, rather than do the long division, because that's kind of a pain, what I'm going to do is I'm going to factor 144. I'm going to find the prime factorization of 144. Okay, now this is going to be 12 times 12. 12 is going to be 3 times 4, 3 times 4. And we've got 2 times 2, 2 times 2. Okay, so take my prime factors. I'm doing this, I mean, by this point, we should really be going pretty quick through these. So let's see, 1, 2, 3, 4 2's, and 2 3's. This is 144. Okay, now 16. If I can divide 16 out of 144, then I have to be able to combine these prime factors here to make 16. And 16 is going to be 4 times 4, which is 2 times 2 times 2 times 2, okay? And you can clearly see that right here, there's our 16, okay? So yes, 16 is a factor of 144, and not only that, I know that 16, this number here, times whatever's left, 9, will give me 144. I could also say that 16 times 3 is 144, okay? So there's a lot of information that's carried in this prime factorization. All right, let's do one more. We'll do a hard one. Let's take a big number. Let's do 5,025. Is this going to work? I don't know. I don't even know what the prime factorization is. I hope this works. Otherwise, I'm going to have to edit this video. Okay, so this number is divisible by 5. So let's divide by 5. And that's going to give me 1,005. Right? 5 times 1,005. Okay, this is divisible by 5 as well. Let's see what I get there. 201. Okay, 201. 201 is divisible by 3 because 2 plus 1 is 3. So that's going to give me what? 6. Just do it over here. Okay. 67. So 3 times 67 is 201. Okay, so the prime factorization, and we know from our factor sheet, from our prime number sheet, that 67 is prime. So 3 times 5 times 5 is 67. Let's go ahead and write that down. Did I say that? 3 times 5 times 5 times 67 equals 5,025. That's what I meant to say. Okay, so I could ask you a bunch of questions about 5,025. I could ask you a bunch of questions. I could ask you, is 15 a factor of 5,025? And I hope you're looking here and you're seeing, yes, 15 is a factor of 525 because I can make it out of its prime factors, okay, out of 5,025's prime factors. Okay, let's see. Is 25 a factor? Sure is, okay. Is 75 a factor? Also, yes, it is. What else could I say? I could ask you, well, obviously 67 is a factor. 14b is going to ask you things like, what's the largest 2-digit number that goes into 5,025? Well, let's find some of them. Let's take a look at these prime factors and let's make some combinations here. So I know that 15 goes in, that's right here. Okay, I know that 25 goes in, that's right here. These are all 2-digit numbers. I know that 67, did I erase that? 25, 67. I know that, what else? Well, 5 times 67 is too big. 5 times, what about this? 3 times 5 times 5. Oh, that's 75, and that's bigger than 67. So this is going to be your biggest 2-digit number. There's no other way I can combine these and get a 2-digit number. Okay. So hopefully that gives you some help on 14b, and this will definitely help you do your online assignment. Okay, good luck.